So welcome to the course on basics of computing. So there are many searching and sorting algorithms available. So one such sorting algorithm is bubble sort. So in many situations in real time, we may have to sort the random list in a particular order, either from ascending order or in descending order. Say for example, if I want to produce a rank list, it has to be in descending order, the highest mark supposed to be on top, and then we can allocate some group or department or whatever the purpose may be. So one mechanism for sorting is bubble sort. We can call the sorting as sorting by exchange. Why the name is given like this? Because we have to take first element and we have to compare with that second element. If the first element is greater than the second element, we will be going for swapping. And the list goes on until we reach the last element. First I will tell you the algorithm, then we will move on to the sample execution. So this is not the complete algorithm, these are only the procedures, the significant procedures in bubble sort. So from the first element of the array, you have to compare the present element with the next element of the array. If the present element is greater than the next element of the array, then we have to swap it. This is for preparing ascending order. Whereas if we want to generate the descending order array, the sorting order supposed to be in descending, then we have to compare for, if it is lesser, then we have to swap. That is the only change. So with this simple algorithm, we can arrange the elements in ascending as well as descending order. And if the present element is less than this next element, go to the next element by repeating step 1. That means what they try to say, if it is not greater, then do nothing, simply increment the iteration value and go for the next iteration. That is what. So this is the array, that is A of 0 is 55, A of 1 is 44, A of 2 is 33, A of 3 is 22, A of 4 is 11. So this is the unsorted array. Though it seems to be sorted, our objective is to sort in ascending order. Just for showing the worst case scenario, we have taken the complete opposite array. So we have to arrange this entire array into ascending order. That is the objective of this problem. Okay. So what is the first step? Once we have declared the array, we have read the values from the array, and then here comes the procedure. We have to take the first element and we have to take the second element. Both has to be compared. Remember, we have to arrange this in ascending order. For that, if the first element is greater than the second element, we have to swap it. So this condition requires a swap because first element is greater than the second element. So once it is swapped, it will be looking like this. So 44, 55, 33, 22 and 11. This is after exchanging, after swapping. So for the next iteration, we are taking the element in position 2 and element in position 3. That is, initially we compared A of 0 and A of 1 and we identified the first element is greater, so we went for swapping. So 44 and 55 has been exchanged and now this will be your present array. Then we have to compare A of 1 and A of 2. So our condition is the first element should not be greater, but here it is greater. So again we need a swap. So once it is swapped, then it will become 33 and 55. Only these two are being swapped, we didn't touch anything else. So 44, which was already swapped, is retained as it is. Then here comes 55 and 33. So once it is swapped, we will be getting 33 and 55 and the remaining elements will be stored as it is. 44, 33, 55, 22 and 11 will be your element. Next iteration is A of 2 and A of 3 must be compared. So this time also the greater element should be in the second position. So we have to swap it. Once it is swapped, we will be having this 22 and 55. and in the next iteration 3 and 4, these two to be compared. Once again we say conclude 55 is greater, which requires a swap. So 55 will be stored in AF4 position. So the entire process is iteration 1. Whereas in each iteration, in this iteration, we have made 1, 2, 3 and 4 comparison. That means the number of elements are 5, that is n is equal to 5, and n minus 1 comparisons we made. Upon completion of your first iteration, your greatest element will come into its position. So you can freeze it. You no need to proceed it further. That means for the next iteration, how many elements we have to process? We will be having only these 4 elements. So when for the next iteration n is equal to 4 means n minus 1 comparisons, that is only 3 comparisons we will be having. This is how bubble sort is reducing the number of comparisons. So we will move on to iteration 2. For the iteration 2, your input is 44, 33, 22 and 11. We should not touch the 55 because in iteration 1, 55 reached its position. So for your next iteration, the algorithm says you have to take the first 2 number, compare it. If the first number is greater, swap it. That is what we do. So 44 and 33 has been taken, which is compared and which is identified as 44 is greater. So we are going for a swap. So that will give you 33, 44, 22, 11, and this is already frozen, so we are not actually going into this part. And in the next comparison, A of 1 and 2 will be compared. 44 is greater, so there requires a swap. If it is not greater, say for example, if I am having 20 over here and 22 over here, then I am comparing it. If it is not greater, then we no need to swap it. Directly we may proceed for the next comparison. So the next comparison will be between 44 and 11. Then also we identify that needs a swap. So which will be swapped, 11 will come into this position and 44 will be placed here. So this is the end of your second iteration. Upon completion of this second iteration, the second largest number will come into its position. That means you are freezing the next larger element in your array. So earlier you have frozen 55, now you are freezing 44. So this is your iteration 2. For the third iteration, you will be having 33, 22 and 11 as your input. 33, 22, 11 as your input, 44 and 55 already frozen. And as per the logic, we have to take these two numbers, 33 and 22, which has to be compared, which is identified as 33 is greater. So we are going for swapping it. So 22, 33 and 11 was retained as it is because that was the previous process task. And then for the next iteration, A of 1 and A of 2, that is 33 and 11 is being compared and it is identified 11 is smaller, so we are replacing. And this is what the end of the iteration 3. So here the number of comparisons in this previous iteration, the number of comparisons 1, 2 and 3, because the array element was only 44, 33, 22, 11, 4. Whereas here the number of elements are 3 and the number of comparisons is only 2, because 33 and 21, 22, 33 and 11. So upon completion of this, we are able to freeze 3 elements. Whether we have completed the task, not yet, we have to go for one more iteration. For the last iteration, what will be your input? Only 22 and 11. These two, the number of elements are 2. So number of comparisons only 1, because n minus 1 comparison, and 22 and 11 has been compared and 11 is identified as smaller, so which has been swapped over here. So there is no more element pending. So we have completed n minus 1 comparisons over here in this iteration, and the total iteration what we have gone is 4. So what is the conclusion is, for an array of n elements, n minus 1 iterations are required, and in each iteration n minus 1 comparisons are required. So upon completion of this task, we will be having the sorted list as 11, 22, 33, 44 and 55. Just for showing you the maximum worst case scenario, we have taken the array in a complete descending order which had to be sorted into ascending order. It is not that in any particular order the number may be, which can be sorted either in descending order or in ascending order. Next is selection sort. The concept behind bubble sort is taking the first element and comparing it with the next element, and if the first element is greater, exchange it. This is how it will be keep on going. That is, we can precisely tell n minus 1 iterations are required for bubble sort. In each iteration, n minus 1 comparisons are required. And the next is selection sort. The logic behind selection sort is it will find the smallest element in the array, and that smallest element will be replaced in the first position of the array. And then it will be next, it will go to the second position, then it will find the second smallest element in the array. The second position of the array will be replaced with the second smallest number. It will be kept on going until it reaches the length of the array. But the disadvantage here is the running time or the number of comparisons depends on the randomness in the order of the array. So the sample data has been taken, which is selected for sorting 88, 44, 66, 99, 22, 33 and 11 are the array elements. So the algorithm is the first position will be replaced with the smallest element. That means first we have to find the smallest element in the array. Already we have come across the algorithm for finding maximum number or minimum number. So if you want to sort it in ascending order, you have to find the minimum number, or if you want to sort it in descending order, you have to find the maximum number. Okay, so this is ascending order. So we are going to find the smallest number. So the smallest number is 11, which has to be replaced with the first position. So this has been exchanged. And next, once it is frozen, because we found the smallest element and we ensured the smallest element is available in its position, then we have to take the second position, and this second position has to be replaced with the next smallest element. So we have to traverse in the array, find whichever is smaller. 22 is smaller. Now 22 has to be replaced in the place of 44, so which is exchanged. Then we have frozen two elements. Then the third position 66 has been taken, which has to be replaced in the remaining smallest element in the array. Whichever is smaller, that has to be taken. So 66 has been replaced with 33. So we have frozen three positions. Then next we have to take 99, and the remaining elements are 44, 66 and 88, and we identify 44 is the smallest. So in the place of 99 we placed 44, and 99 has been placed in the position of 44. So we have completed 4 elements now, and next we have to take the 99. We have to find the place whichever will be occurring here. So the 66 is smaller. So 66 and 99 has been exchanged in its position. Here it is nearly available. It is not that only the next element will be searched. We have to search whichever is smaller in that position. This element has to be replaced. So 66 has been replaced, and the remaining is only 99 and 88, which has to be compared, and then 88 is identified to be smaller, which will be frozen, and finally we have 99 in its position. So like this, the algorithm is find the smallest element in that array, keep it in the first position. Next, apart from the first position, find the next smallest element in the array, keep it in the second position, then leave these two in the remaining array, find the next smaller element, keep it in the position and traverse till the array end. So once it is completed, the sorted list will be 11, 22, 33, 44, 66 and 88, 99. It will be like this.